Good day everyone. Today I will be discussing integration testing, bridging the gap of reliable software. When we build software, it's not enough to test individual parts separately. Even if each part works perfectly on its own, problem can still happen where they interact with each other. That's where integration testing comes in. It helps ensure that different components of a system work together smoothly, reducing bugs and improving reliability. In this presentation, we'll explore what integration testing is, why it matters, the challenges involved, and modern solutions use real-world development. The testing landscape beyond unit tests. Let's first understand where integration testing fits in the overall testing landscape. We have three main types of testing. First, unit testing. This focuses on testing individual components in isolation. It's fast and great catching logic errors, but it cannot detect issues between components. Second, integration testing. This verifies how different modules work together. It helps catch bugs that only appears when systems interact. Lastly, system or end-to-end testing. This tests the entire application from the user interface down to database. While comprehensive, it's slower, more than fragile. So, integration testing sits in the middle. It connects unit testing and full system testing. Why integration testing is hard? Now, integration testing is very important, but it's also challenging. One major issue is dependency problems. Tests often rely on databases, IPIS, on message queues that must be properly configured. Another challenge is brittleness. Even small changes in one component can break tests, leading unreliable results. We also have slowness. Setting up environments takes time, which slows down development. Finally, diagnosis difficulty. When something fails, it's harder to identify which component caused the issue. Because of these challenges, developers sometimes avoid integration testing, but that leads to bigger problems later. The problem with manual setup. Traditionally, developers set up their testing environments manually. For example, they may need to start Docker containers, databases, or services every time they begin working. This leads to a poor developer experience because it's time-consuming and prone to mistakes. Also, different developers may have different setups, causing the common problem: it works on my machine. This inconsistency can create confusion and delays in development. Introducing test containers. To solve these issues, modern tools like test containers are used. Test containers is a library that allows developers to run dependencies like database and services inside Docker containers during tests. It automatically manages the lifecycle, starting and stopping containers when needed. It ensures services are ready before test runs, avoiding timing issues. It also supports complex setups and allows tests to run in parallel, improving speed and reliability. Overall, it simplifies integration testing and makes it more consistent. Test containers in action. Test containers can be used in many real-world scenarios. For example, it can run database like PostgreSQL or MySQL for testing. It supports messaging systems like Kafka and RabbitMQ. It can also simulate web services like Elasticsearch or Redis. Even browsers like Chrome and Firefox can run inside containers for testing user interfaces. And if needed, developers can run any custom Docker image as parts of their test environment. This flexibility makes it a powerful tool for integration testing. Modern integration testing for JavaScript. In JavaScript, tools like Cypress simplify integration testing. They are easy to use and provide clear feedback when tests fail. They also allow interactive debugging, helping developers quickly identify and fix issues. Spring Boot integration testing strategies. For Java developers, Spring Boot offers several strategies. Use embedded databases, fixed tests. Spring Boot test loads the full application. Transactional ensures clean tests data. These tools help create reliable and maintainable integration tests. The test pyramid. Now, let's look at the test pyramid, which shows how different tests should be balanced. At the bottom, we have unit tests. They are fast and curious. In the middle are the integration tests, fewer than unit tests but essential for certain interactions. At the top are end-to-end tests. Tests are the slowest and should be limited for critical scenarios. A good testing strategy uses all three levels together. Integration testing plays a key role in connecting unit tests with real-world system behavior. The future integration testing. Looking ahead, integration testing continues to evolve. One trend is fail fast, where integration tests are run early to catch issues sooner. Another is containerization, with tools like test containers becoming standard. Automation is also improving, with build tools like Maven and Gradle make testing seamless. These advancements help developers build more reliable software faster.